Hi everybody, welcome to my video on factorisation. Now I've said GCSE at the top, however that might be a bit of a lie because some of the work that I'm going to be covering is more like A-level, okay? But if you're at GCSE, give it a go anyway. The most part of it you should be able to do. It's just the last couple of questions that are tricky on each exercise. So I'm going to do this as a lesson format, and what I'm going to do is show you examples, give you some questions, and if you're lucky I'll go through the answers to the questions too. So if you want a more in-depth overview of each of these topics, please see other videos that I've got, because this is more of an overview, assuming that you've seen it all before. You just need a bit of revision, a bit of a recap, and obviously, as I've said, I'm going to stretch you a little bit more, and we're going to look at some more difficult, challenging things too in this video. So, starting off with this first linear factorisation, we're looking at two terms, and we're looking to see what is common in both terms. Now, when I say what is common, are any letters common? Or are the numbers common? Now, for a number to be common, it has to be a common factor. Okay, so in these linear ones, this is what you're looking for. Now, no letters are common because we've got an x here, but no numbers, no letters here. Okay, so we can't take any letters out as a common factor. But from 12 and 30, we need to think about a common factor and actually the highest common factor. What number goes into 12 and 30? Okay, so you need to think 6 goes into 12, 6 goes into 30, and there's no bigger numbers than 6 that you can use. So we put 6 outside a bracket. Now we think, what would we have to times 6 by to get 12x? Okay, and the answer is 2x. And then you think, what would you have to times 6 by to get 30? And the answer is 5. Notice you want minus 30, so there's a minus there. That's your answer. Example 2. We're looking for common letters. Here we've got x squared, which you can think of as x times x. Okay. Now I don't want to say 2x's because that would be 2x, but you've got x times x, you've got x twice effectively. And here we've got x. That means that x is a common letter in both, so you can put that ready outside the bracket. Now you look at your numbers. Are there any common factors of 6 and 2? Yeah, 2. Okay, 2 is the highest common factor of 6 and 2. So we've got all the terms that we can get outside, and now we need to think about what goes in the bracket. What do you times 2x by to get 6x squared? Well, 2 times 3 gives you the 6, and you need an extra x to get to x squared. Now, what do you have to times 2x by to get 2xy? You've already got the x, you've already got the 2. All you need is the y, and it's a negative. So that is your answer. Okay. Next one, looking for common letters. So here we've got x cubed, which you can think of as 3 x's times together. Here, x squared, 2 x's times together. Okay. So if you imagine this one, x, 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 here, x, x. So what's common in both is 2 of the x's, which is x squared. Okay? And similarly for the y's, you've got y times y and just y, so y is common in them both. Looking at the numbers, the highest common factor of 9 and 18 is going to be 9. Okay? Now we open up our brackets, and we think, what has to go in? What do we have to times 9x squared y by to get 9x cubed y? So a bit of a spot the difference. You need one more x to be multiplied, and you need one more y to be multiplied. So xy will go there. The next one, what do you have to times 9x squared y by to get 18x squared y? Well, you've already got your x squared, you've already got your y. All you need is 2 to times 2 by 9 and get 18. And it's a negative. Okay, that's your answer. Simple as that. Hope that was clear. Okay. One more tricky example. This is what I'm talking about is your A star or going on to A level. Okay? Because it looks horrible. You've already got brackets in there and it's telling you to factorize still. So now I'm going to start using the word thing. Okay? We've got this thing here and this thing here. And those things are common. And what do we do with common things? We take them outside the bracket. So the 2x minus 1 is the common thing, and I'll highlight it so you can see where it's come from, the common thing that we've taken outside our big bracket. Okay. Now we think, is there anything else that we can take out? No, there's nothing else that's common. So what do we times this 2x minus 1 by to get 3x times 2x minus 1? So the answer's in what we just said. You have to times it by 3x. Next, what do we times 2x minus 1 by to get minus 4 times 2x minus 1? The answer is in what we say, minus 4. So if you've seen double brackets before, this is going to look quite familiar to you. Okay? So there's more than one way that we can factorize into double brackets. And starting off with this thing is just one of those ways. Right, 4 questions there, some of them getting quite tricky, and 7 questions for you to try. I must be feeling kind today because I'm going to go through and do all these for you in a second. So that means in your time zone you want to pause the video, have a go at these 7 questions. I don't care how long it takes you, I just want you to try your best and try and get them all right. Then come back to the video and let's have a go. So my time zone, I'm carrying on and I'm going to do the answers now. Hopefully you've paused, had a go yourself. Let's go for it. Shall I highlight so you can see what's common? X common. So we take out the x and there's no numbers common, we just get 3 plus y. Okay. Here we've got 4 and a 2. So 2 is a common number. Okay, common factor. And x is common in both. To get from 2x we need to times by another 2x to get 4x squared, and we need to times by minus y to get minus 2xy. Next one, question 3. P is common. Here we've got p times p, here we've got p. Q is common. Here we've got q times q, and here we've got q. So what do we have to times pq by to get our pq squared? Well, an extra q. What do we have to times pq by to get p squared q? An extra p. Okay, done. Next one. Common factors of numbers. 3. Common factors of letters. Q. Okay, what do you have to times 3q by to get 3pq? A p, of course. What do you have to times 3q by to get 9q squared? Another 3q, and it's negative. Okay. Next one. Common numbers. Common factor of 2 and 6. Highest common factor, to be exact, is 2. I won't put that in yet. We've got x cubed and x squared. So x squared is common. We need to multiply by an extra x to get to 2x cubed. And we need to multiply by 3. And we don't need any more x's. We've already got the x squared. And it's a negative. Next one. Common, highest common factor is the number 4. Factors that are common. Here, a to 5 is a times a times a times a times a. A cubed, a times a times a. So we've got a times by itself 3 times in common, aka a cubed. Here we've got b times b, b times b times b times b, b squared is common. What do we have to times 4a cubed b squared by to get 8a to 5b squared? Well, we need an extra 2 more a's to be multiplied, and we need the number 2 to be multiplied. So 2a squared. Okay. To get to 12, you need 3. 3 times 4. And we've already got our a's, but we need an extra b squared to get to b to 4, and it's a negative. Right, on to the tricky one that we talked about in example 4. The y minus 1 is the common thing. So that gets taken out. Okay? And then what goes inside the bracket is what you need to multiply by. 5y in the first case, add 3 in the second case. Okay? There's your answers. How kind am I today? Doing all your work for you. Okay. So, example 5. Moving on to quadratics. You can see they're quadratics because it's x squared. Okay? And because there's no y's involved or any of the letters, x squared, and then an x term, and then a constant term, which means it's a quadratic in x. This calls for a slightly different method. We know because of it being a quadratic in this form with 3 terms, we're going to have 2 brackets. And if you undo this method that we're going to do, you're doing the banana method. So factorizing this quadratic is the opposite of the banana method from my other video. And this factorization method says we need to multiply to make the number on its own. So we need to multiply to make minus 10. And we need to add to make the number in front of the x coefficient. So if we want to multiply to make 10, add to make 9, we're probably thinking about one's got to be a plus and one's got to be a minus to get to a minus number. So it's minus 10 plus 1. Okay. So you could write out factors of 10 here because they're going to multiply to make 10. One's got to be plus, one's got to be minus. And then the one that you want to pick to make minus 9 is minus 10 plus 1. As I've said, there'll be other videos where I go into more depth on this. Now I have just done another video on this one where we've got a coefficient of 6 in front of our x squared in our quadratic. In my method, I put 6x, 6x, okay? And this is called the quick trick method because it's so quick and so cool. I know you're thinking, well, when you times that out, you get 36x squared, so it's wrong. Fine, let's put a 1 over 6 in there, okay, to make it right again. Now, we're looking for numbers in my method that multiply to make 6 times minus 12, which gives us minus 72. So we've got to multiply to minus 72. We've got to add to this number in front of the x, which is an invisible 1. So effectively, 2 numbers with a difference of 1. One's plus, one's minus, because they multiply to make a negative. Okay? If you know your times tables well, you're probably thinking 8 times 9 is 72, and they've got a difference of 1. Fantastic. So let's go for plus 9 minus 8, because we want them to add up or take away to make 1. Okay? If you did it the other way round, then you'd have 8 take away 9, which would give you minus 1. Now, we've got to finish my method off. We've got a 1 over 6 to get rid of. So let's divide this by 3. Let's divide this by 2. And that gets rid of our divide by 6. Okay? 6x divided by 3 is 2x. 9 divided by 3 is 3. 6x divided by 2 is 2x. No, it isn't. It's 3x. Just testing you. 8 divided by 2 is 4. There's your answer. There's a whole video on that. It's a difficult method, but once you get it, bang, you get the answers because it's such a quick trick and classic method. Okay? Question 7. Example 7. Oh, now, if you think about this one, what we need is something that's going to multiply out and give us this. Okay? Now, this is a bit of a trick one, really. And it's called the difference of 2 squares. Okay? Difference of 2 squares. Can you see we've got the x squared and the a squared? Okay? So they're both squares, square numbers or whatever you want to think of. Geometry, this works as well as a picture. And we're taking away, so it's a difference between them. And there's a formula for this, which is x minus a, x plus a. Okay? So what that means is when you multiply out, you're going to get x squared. you're going to get your XA, you're going to get your minus XA, and you're going to get minus A squared. This is where the method comes from, because plus XA, take away XA, are going to disappear. Okay, so that's one for you to think about and learn. So it means that we can factorize things like this where there's only two terms. Now because maths is so awesome, different methods tie in. So the method that we just talked about still works. We've just got 0x and minus 9. So we want to add up to 0. We want to times to minus 9. The only way we can add up to 0 with two numbers is if one is the negative of the other. So like 100 take away 100, 0. 1,000,001 take away 1,000,001, 0. Okay? Well, guess what? Your numbers also have to multiply to make 9, which you can get by doing the square root of 9 is 3. So with our old way, our two numbers that add to make 0 are 3 and minus 3, and they also times to make minus 9. So the old method still works, but there's a quicker way. You can think, well, this is x squared, and it's minus 3 squared. And the difference of two squares tells me it's going to be x minus 3, x plus 3. Okay? Two ways, up to you. Really don't mind. Can be a bit more tricky, like in example 9. We can take a factor of 2 out before we start. We've got x squared minus 4 in the bracket. Okay, we've learned about that factorization already. Looking what's inside this bracket is the difference of two squares. X squared minus 2 squared. So we keep the 2 outside, and from inside the bracket we're going to get x minus 2, x plus 2. Okay? So we've used difference of two squares and linear, normal, single bracket factorization there. Okay? Example 10, getting really difficult now. This looks pretty horrible because you can see, well, x here common, and a y here common. What have I just done? Did I just delete that page? Definitely did not want to delete that page. Oh, I haven't deleted it. Phew. Okay. Anyway, x is common, y is common. Okay, so it looks confusing. Now let's just see what happens if we look at the first term here. From the first term, we can take out an x. Okay, and we get 2x plus y. Now if you're thinking 2x plus y looks very similar to this minus 2x minus y. The only difference is there's a minus there. So let's take the minus outside the bracket, okay, and have 2x plus y. Because if you have a minus outside the bracket, it's minus one lot of it, which would mean you have minus 2x minus y. Okay, so that's how to factorize a negative sign. Now, notice what we've got here. We're tying it all together. We've got this thing in common. So we can take that thing outside as a common factor. And then what we've got to multiply to get the first term is x, and to get the second term is minus 1. Okay? Pretty tricky question there. Quite a weird one. Okay? But like I said, I was going to put in some extensions, challenge you a bit. Moving on. Some questions for you to try. Same routine as before. Pause the video, have a go, and come back and join me again for some answers. Okay. Right, x squared minus x minus 6. Well, there's a minus 1 in front of the minus x, just to make your numbers easier. So we're trying to multiply to make minus 6, and we're trying to add to make minus 1. Because it's a minus that we're multiplying to, one has to be plus and one has to be minus. Okay, so we want two numbers, 1 plus, 1 minus. Times to make 6, they've got a difference of 1, it's 2 and 3. Now because you're trying to add to a negative, you want your bigger number to be negative. Okay, because then you're taking it where you're going to go below 0. 2 take away 3 gives you -1. Done. Next one, we have to multiply to make -16. We have to add to make 6. Two numbers, one's plus, one's minus. So x plus 8, x minus 2. Okay, you can check that one yourself. Hopefully you got it though. Harder method, okay, my quick trick method. What we do with the quick trick is 2 times 2 is 4. We've got to multiply to make 4. We've got to add to make 5. Okay, now there's an extra trick involved because we put the 2x, 2x. And of course our numbers are plus 4, plus 1. We need to get rid of a 2, divide by 2. We can get rid of it out of the first bracket. So what we're going to get when we divide this by 2, you don't need to divide both brackets by 2, just the one. So it's going to be x plus 2. Job done. This one's a bit tricky. What you could do is you can think, well, look, basically we're just going to take an x out, aren't we? Okay. Now remember I said how cool maths was. Check this out. Okay, you could do it linearly and think, take out x and just have one bracket, -3, done. Or, remember I said all the methods tie in? You're going to love this one. Okay, so add on 0. Numbers now have got to multiply to make 0 and add to make -3. Okay, well, it's a bit of a trick one, but 0 minus 3, because anything times 0 is 1. So we put our numbers in. Okay, we put in plus 0 minus 3. Hold up, what's the point in writing x adds 0? We don't need to. Okay, we don't need the plus 0. And why do we need a bracket around x on its own? Look how awesome that is. Same answer. Okay, two different methods. Right, next one. Moving swiftly on from that. -6. They've got to multiply to make -6. They've got to add to make 5. Okay, so it's going to be plus 6 minus 1. Don't forget my method. Put your 3 outside. Okay, now I've got to divide by 3 to get rid of. Don't worry, we can do that. We can just divide the first bracket by 3 and we've got rid of it. Done. Nice one. Right, 7 times 3, 21. They've got to multiply to make 21. They've got to add to make -10. So they're going to be both minus. To multiply to make a negative and to add to make, to multiply to make a positive and add to make a negative. Okay, and your two numbers, -3. I'm forgetting my own method. I'm using x instead of y. I am so sorry. 7y, and we said our numbers were -7 and -1. Okay, now we need to get rid of that 7, 1 over 7. So we divide the first one by 7, job done. Look at that. Okay, question 8, I've just realised I missed out question 6. Maybe I didn't like the look of it. Subconsciously, I don't know. But believe me, I'm not going to shy away from question 6. 2 times 21, 42. Okay, we need, maybe I should have done, we need two numbers that multiply to make 42 and times to make, and add to make 17. Okay, so you're going to see my working out process now that I'm going to do in your head. I'm explaining to you everything in my head. How lucky are you? I'm thinking 15 and 2 has just sprung out at me, but 15 times 2 is not going to give you the 42. Okay, looking for maybe an odd and an even. Okay, 3 and 14. 3 add 14 is 17. 3 times 14 gives us what we want. Okay, 42. Now notice it doesn't matter which way round you put these in, as I hope you already know. Okay, now I've got to get rid of divide by 2, which we can do in the second bracket. Change it to y, add 7. Now we've done our duty of dividing by the 2. Okay, back to question 8 now. 10x squared plus 5x minus 30. Okay, now, word of warning. Some of you guys are probably looking at that thinking you can divide everything by 5. So you might write down, awesome, 2x squared plus x minus, what we're dividing by 5, minus 6. Okay? And you might write that as your next working out step. Are these two things the same? No. So you can't put that equals that. If you want to divide by 5, you have to put a 5 outside. What you're thinking of is when, if you've thought that, is when you've got it equal to 0. Because then if it's equal to 0, dividing everything by 5 won't matter, because 0 divided by 5 is still 0. So just a word of warning, because I've seen people do that. So one way we could do it is take that 5 outside. I'm all about different methods today. So let's do it this way. Take the 5 outside, factorise, we're looking to multiply to make minus 12, and add to make x. Okay, so our numbers are going to be, we've still got that 5 outside with this way round, and we've still got to divide by 2, so let's put a half involved, and we have 2x, run out of space a little bit, and our numbers are going to be 4 and 3, plus 4 minus 3. Okay. Now the bracket that we can simplify a little bit is the first one, because we can divide by 2 to get x plus 2. Okay, and that is your answer with a 5 at the front. Now let's see what happens if you didn't notice about the divide by 5, because you don't have to. There's no rule telling you you must notice to divide when you can. Okay, 10 times minus 30 minus 300. Okay, and we've got to multiply to make the minus 300, add to make 5. I might wish that I hadn't said this second method, but let's have a go. Now the trick is, because it's ending in a 0, your numbers have got to end in a 0 or a 5 to multiply to make 300. Okay, now because they add to make 5, and 1's plus 1's minus, they've got a difference of 5. So both your numbers are ending in, one's ending in a 5, one's ending in a 0 from deduction. Okay, now let's think about what might multiply to make 300. Well, they've both got to end in 0 and 5. Should we try, I don't know, 15 and 20? Would that be a good guess? 15 times 20 gives us a 300, and then you can have 20 take away 15. Okay, if we'd have done it this way, apologise for setting out now, let me just rub out our second question. I'm going to write our answer here, a little bit messy, but I've already shown you the answer. I'm just showing you a different way now. What we would have got, we would have divided by 10, we would have had 10x, we would have had 10x, we would have found our numbers, slightly more difficult to find, but we would have found them. Now I've got to divide by 10 to get rid of. Okay, so we could have divided by 10 fully from the second bracket. Okay, fully from the second bracket. So we get x plus 2. Doesn't want to give me that. So I'll just do it in pen. X plus 2. Okay. Now, you're thinking, well, we've got rid of that. We've got 10x minus 15, x plus 2. And I told you they were going to be the same. Well, this can be factorised. Take out a common factor of 5. And you get left 2x minus 3. Okay. We haven't messed with the second bracket. That's still x plus 2. Like I said, you've got exactly the same thing. How cool is that? Okay, like I said, when you multiply, it doesn't matter the order which way around. Right, more questions then. Have a go. Try and do question 9 to 14. We're getting hard now. We're getting really tricky. Okay, so pause it for as long as you need. try your best. Well, even rewind back and look at the other ones, okay? See the techniques that we've looked at, see if you can solve these. The hardest one is 14. I'm giving you a little bit of a clue there, okay? Anyway, off you go. Pause it, have a go, come back and join me. Right, carrying on. In my time, no time has passed. With you, maybe half an hour has passed. Maybe 12 minutes. I don't know. You're the boss. Okay, anyway. 4x squared take away 25. This can be written as 2x squared. That means 2x times 2x because that gives us 4x squared. This can be written as 5 squared. Now it's a takeaway, so we've got the difference of two squares, and our two things we've got are 2x plus 5, 2x minus 5. I told you it's difficult. That's A star GCSE, or that's your A-level maths there. Okay. Next one. Let's see what we can do with question 10. Okay, so the second half of it, I'm thinking we can take out a y. This part I'm looking at and I'm thinking we can take out an x. So let's take out an x for the first part. X minus 3. Ideally, we would want another x minus 3 here. Now, if we just take out y, actually, what we would have got is a minus here and a plus here. Now, if you want to swap the signs inside the bracket, whack a minus in front. Okay, a little top tip for you there. Now, we've got this thing in common in both. Okay, so we factorize it out, the x minus 3. We've got x minus y of them. Okay, that's a hard one, I'll grant you that. 11. Okay, like we talked about, if you want to, I'm not going to show you two methods for this because hopefully you've solved it in your own way. Method I'm going to do is take out 4. Okay, because this quadratic we're left with is easier to solve. We're looking to times to make 2, add to make minus 3. So we've got to both be negative, and the numbers we're talking about are minus 2 and minus 1. Okay, question 12. Tricky one again. This can be written as 4m all squared. Okay, because 4m times 4m gives you 16m squared. 81n squared can be written as 9n all squared. 9n times 9n gives you 81n squared. It's the difference of two squares because it's taken away. It's this thing squared and this thing squared. So you get 4m plus 9n, 4m minus 9n. Doesn't matter which way around you put those brackets. Question 13. Not a very nice one by the look of it. Is the difference of two squares going to come out? I think it will. Ooh. Factorize out a y like we did in the very start of this video. 4y squared minus 9a squared. Now look at this. We're not finished because inside of this is the difference of two squares. Okay? And we're talking about 2y being squared, and we're talking about 3a being squared. So when we factorize, we've got a y waiting outside, and from this bracket, that's just the same y as here. From this green bracket, we go from a difference of two squares to 2y plus 3a and 2y minus 3a. A really tricky factorization here. Okay, goes way beyond GCSE. Right, 14, the final question. Think of this x plus 1 as one thing on its own. Why not even think of it as an x? Okay, different x, a big capital X. Look what we've got. We've got 8 big X squared minus 2 big X, take away 10. If you just saw that written out, you'd think that's a quadratic to factorize. Okay, that's exactly what it is. But this is a horrible, tricky question for you to do. Okay, we're going to need a bit more space here. So, we would go about trying to factorize that. And what we can do is first off, take out a 2. Okay, so we take out a factor of 2 and we get 4 big X squared, take away big X, minus 5. We've just divided each term by 2. Now what we're going to do is factorize this thing in the big bracket using our technique that we talked about. We're going to have 4x and 4x, but that means that we've got a quarter outside just to balance things out again. Okay, and don't forget actually that outside all of that is a 2. Okay, waiting for us. If you want to jump the gun a little bit, you can think, well, wait a minute, what's the point of me getting rid of the quarter and then times them by 2? 2 times a quarter is a half, so all I have to get rid of is a divide by 2 actually. Okay, hope you follow what I just did there. Anyway, back to what we're actually doing, which is looking for two numbers that multiply to make minus 20 and add to make minus 1. Okay, there's a 1 coefficient there. So our numbers we're talking about are 4 and 5, and it's plus 4 minus 5. Okay, so now we take out our 2, which we want to take out. We take it out of this bracket, we get left with 2x plus 2, 4x minus 5. Remember, we were only using the big X to represent x plus 1. Okay, so now what we have to do is put x plus 1 back in its space. Okay, that's x plus 1. That's x plus 1. It's actually called a substitution, what we've just done. I just didn't make it explicit to you. So when we write that back in, what it actually was, 2x plus 1 plus 2, 4x plus 1 minus 5. Okay, we want to simplify this. It does not look very nice, I'm sure you'd agree. Times out. An expansion within a factorization question here. Okay, so times out that first bracket, you get 2x plus 2, and we've got another plus 2 there going on. Times out the next bracket, and you get 4x plus 4, and we've got a minus 5 going on. Now this can be combined together. We can do 2 add 2, so we get 2x add 4, and we get 4x minus 1. That's your answer. If you really want, you can take out 2 from this and put x plus 2, 4x minus 1. So that means that actually, another way to write this thing is that. Okay? Very, very hard question at the end. Give yourself a pat on the back if you got that at home. Well done. Okay. Anyway, that's our factorization lesson all done. Starting pretty easy, working up to pretty hard. Okay. Hope you've enjoyed that, and I hope you've learned something from it. Good luck and achieve maths.